Hi, welcome to another video tutorial in which I'll be going through a little introduction into Dijkstra's shortest path algorithm. Now, Dijkstra's shortest path algorithm is an algorithm for finding the shortest path between nodes in a graph, similar to the one that I've got to my left here. Most frequently implemented so that you pick a single node such as Southampton in this graph, and that's your source node, and then the algorithm will tell you the shortest path between Southampton and all of the other cities. And some applications of Dijkstra's algorithm then. One application is that we can use it to find routes on road networks. So this graph that I've got over here is a very abstract version of roads in the United Kingdom. And another application is using it in packet switching, so finding the shortest path between two routers for a packet in a computer network. And these sorts of shortest path algorithms form the basis of satellite navigation applications such as Google Maps. And next I'm going to show you how to apply Dijkstra's shortest path algorithm to find the shortest route between Southampton on this graph and all of the other cities. In the next part of this tutorial video I'm going to be sort of tracing the algorithm here and showing you how we actually apply it to this simple graph here. And I've got the steps of the algorithm down here written out in the clearest way I could think of to describe it. And what the first step is to assign a temporary distance value for all nodes, a 0 for the source node and infinity for the others. So we'll do that now, and these are my columns for my current shortest path from S to my other nodes. My path from S to S is just going to be 0. That's why I have 0 for the source node, because we're already at Southampton, so we don't need to move any distance to get to Southampton. But we haven't looked at how far, or we don't even know if there is a route from Southampton to anywhere else on the graph yet. So I'm going to put an infinity sign in the rest of them. Okay, so I just realised that I don't actually need that column there. The next thing that we do is we update the distance values that we've got for all the nodes connected to the source node. So the only node that's connected to our source node, Southampton, is London, and that's a distance of 80 away from Southampton. So we can update our current shortest path to London with 80. Our shortest path to Southampton is going to remain 0 for the whole table, and we still haven't visited London, so we don't have a path to any of the other nodes. So we're going to keep those as infinity signs. Okay, and then I'm going to visit London. I'm going to put that in my visited section there, so I know I've visited it. I could also mark this on the graph, which may be easier. So I can say that London took me 80 to get to. Cross London off there. Then I can need to, so I've done this, pick the node with the shortest distance to it and visit it. So I've visited London, and then I've got to repeat steps 2 and 3 for nodes connected to the visited nodes, making sure that I add the distances up. So if I'm going to Bristol, my shortest path from Southampton to Bristol is 80 plus 20, not just 20. And until all of my nodes have been visited. So I think I'm actually going to mark the visited nodes on the graph because I'm going to run out of space over there. So our next step then is to have a look at all the other routes that have now been opened up to us. So we've got a route from Bristol, from London to Bristol, and from London to Oxford. So we can have a look at the distances. So we've got 80 going to here. So 80 plus 20 to Bristol is going to be 100. So for Bristol, I'm going to put in 100 in there as our current shortest path. And to Oxford, I'm going to do 80 plus 60. which is going to be a distance of 140, and our current shortest path to London is still 80, and it's going to remain 80 for the rest of the table, but we still don't have a route to Birmingham. And because I've visited London now, I'm going to have a look at the shortest route that I've got opened up to me here, and the shortest route is 100. So I'm going to move over to Bristol. So I've visited Bristol, and because I've visited Bristol, I've now got a connection to Birmingham. And my connection to Birmingham is 190. And that is going to be my new shortest route, because 190 is a shorter route than infinity. So I'm going to pop that in there. And my other routes to Oxford and to Bristol. Bristol is going to be 100 for the rest of the time because we've visited Bristol. And my shortest route to Oxford is still the shortest route because there's no connection between Bristol and Oxford. So we're going to put 140 in there. The next thing I'm going to do is pick the shortest route out of these two nodes that I haven't visited yet that I've got remaining. So that's Oxford, so I'm going to visit Oxford. And that's given me a new route to go to Birmingham. And that new route is going to take me 140 plus 80, so that's going to be 220. I've visited Oxford, so I'm going to fill that in with 140s. And because my new route to Birmingham is longer than my previous shortest path, I am not going to put that in because that's a longer path than my previous shortest path. So I've actually now, at this stage, worked out all of the shortest routes. There we go. In my final column of the table, I didn't really need this column row, but I've now left in my table the shortest routes from Southampton to all the other nodes. So my shortest route to Southampton is 0, to London is 80, to Oxford 140, to Bristol 100, and to Birmingham 190. Now, I haven't actually seen any exam questions on Dijkstra's algorithm for computer science, so I don't know what sort of table they're actually going to ask you to trace in the exam, certainly for AQA anyway. But in a future tutorial, I'm going to go through how to implement Dijkstra's algorithm with a priority queue. So you'll be able to understand that and be able to answer questions on that. Okay, that's the end of this tutorial video. Thanks for watching.